we're ready to deploy on a Friday evening without any care. So we just press the deploy button and we go home without even checking the deploy pipeline on the
I'm glad
PC.
you said it. Hi, I'm Nick Cosentino, and I'm a Principal Software Engineering Manager at Microsoft. In this video, I got to interview Vasilii Oleinic about his journey in software engineering, software architecture, and testing as well. Of course, with all of these interviews, we get to hear these cool stories from different individuals and how they got to where they are, so Vasilii is no exception in this case. What I really liked about this conversation was hearing about how he approaches software architecture, proof of concepts versus scaling out applications and building them to be the real thing. Now, something else that probably caught your attention is that Vasilii wants to work towards deploying on Friday evenings, and I am totally behind that. So I think you're totally going to enjoy this conversation. Sit back, enjoy, and let me know in the comments if you like this kind of content. Thanks, and I'll see you next time. Cool. Okay. Well, Vasilii, do you want to give us a little bit of background for how you got to where you are in terms of software development and your journey for what that looked like?
Sure. So it's gonna sound weird, but I'm coming from a musical background.
Cool.
So both my parents are musicians. They never wanted me to be a musician, so they tried to pursue me in automotive engineering stuff. But I always liked programming since I was gaming from the early childhood. So I was first doing some mods for different games, then trying to meddle up with the code base of the games just to get myself some unfair advantages that I wanted in specific games. But yeah, at some point in high school, I started programming. It was way back with Pascal stuff for different, how are those called? Um, not really exams, but basically Pascal in school and all that
Sure.
stuff. And then I got into university where I started with .NET. Well, we were taught C and C++,
Okay.
and then at some point Java. I hated Java from the get-go because I knew C Sharp by then. I mean, at this point, I understand that it was unbiased, but I didn't like Java at all back then.
Right.
So yeah, it was first course when I got into work. So I tried to combine uni and work together at the same stuff at the same time. So here we are, I think 6 or 7 years later. I'm working as a senior engineer in a bigger company that I started off in a really, really small company. And thanks
Okay.
God I started over there. It was more like a startup environment, let's say so, where there were not many engineers. They
Mm.
weren't the best practices in the world, but you could do everything from the get go, from business analysis to talking directly with the clients, figuring out how to do stuff and all those things. Somewhere along the line, that's when I really loved the idea of good architecture
Hmm.
because I had a project. I worked at the start of the project was one that we had to wait for 20 minutes for it to build in order after we do some changes in C Sharp because it was a chimera of sorts. It was a
Okay.
really, really big project that essentially it was a test at low code stuff. So basically you just load up the entire thing, the entire the entire solution itself.
Right.
And essentially it's was combining PPMN's stuff with workflow engines and all that stuff. It was a try to do that. So essentially we had a lot of nightmares going through that. And that's when I decided that, hey, I want to see what a really good solution looks like.
Sure.
Uh, by that point, I think it was the first time I saw Mediator and the clean architecture and Onion style, and I was like, okay, so you could do it like that also, not only scrapping everything on one plate. So yeah, it was about a year and a half probably into my entire engineering journey when I started looking at architecture, and I dreamt of becoming an architect, but my vision back then of what an architect does and
Right.
my vision right now of what an architect actually does are two different things.
Right.
At first, you think only about your small solution, about how you're gonna write the code, how the folder structure is gonna be like, and afterwards, you understand that it's not only that; it's about testing, deployment, how it all works together, how it all brings the most important part, how it all brings value to the client,
Right.
how certain stuff, how different uh, decisions you take impact the overall workflow of your team, of your teammates, basically how productivity impacts, how to manage technical backlogs, how to manage technical backlogs slash technical debt items, how to get the client to know that, hey, we need to stop a little bit the feature grind in order to clean up our messes that we've done over the last couple
Sure.
of sprints in order to be able to deliver at the same pace in the future. Because I've had cases where we were on a feature grind, and then you just look at the mess that you've built over the last couple of months because you couldn't explain to the client that, hey, we need to stop, we need to regroup a little bit and start it over again. But I think I went over from the topic itself about presenting. But yeah, that's basically how I got into all that. So it was a messy start that got me into architecture, into testing, because from where I'm coming from, the companies don't usually pay that much attention to testing, at least the
Yeah.
region where I was born. Right now, I'm working in another country, but the region where I was born, most of the smaller companies don't really pay that much attention to the testing process. Essentially,
Right.
sometimes it's not even existing, and you have only manual testers on your team, or developers do the manual testing themselves without
Right.
any kind of unit tests. So that's part of the reason I got really interested in testing, in unit integration, on all different kinds of testing, because I hated doing the clicking myself. So I loved
Sure.
the idea of having some automated process in the background that does it for me, because I'm historically not really that attentive when it comes to doing the same thing over and over again, manual stuff. I
So
don't know if it's
typical
just me.
typical software developer.
Yeah, as it's typical software stuff that I personally didn't like it, and that's why I went into unit testing. Um, yeah, so that's where my passion came from. At some point, we over-engineered something, but I found my gig about the approach that I like to bring to the table, and which brings return on investment, really,
Right.
a really good return on investment. So that's
Yeah.
probably finding the sweet spot is really the amazing thing here.
That's hard to do, right? So you said a lot of awesome stuff there. I wanted to mention that your kind of initial, journey into software development, like even as a kid, it's almost the exact same as me. I've said this on recorded sessions before where I was like, before I could actually program, it was like I'm playing video games and I'm trying to look for how I can get a little bit of an advantage. So I'm messing around with config files and just remember being like,
Yep.
okay, how can I start messing around with things more? Because I want to be able to do more. So very similar. I thought that was kind of funny. I wanted to ask a little bit about um, so you mentioned when you started working, especially at smaller companies, and I've observed a very similar thing where, especially at smaller companies, it kind of feels like a lot of the time it's as startups just trying to survive, right? Like we got to get features out, we got to get value to the customer, and as a result, it feels like most of the time we're cutting corners. Like when you kind of zoom out and you can see how software is developed other places, feels like cutting corners a lot. So I'm curious, have you noticed a very big difference being at a larger company now compared to a smaller one in terms of those
Uh,
practices?
okay, so in terms of those practices, larger companies are a little bit on the slower side. So it takes a little bit more time to deliver a specific feature in a in a larger company, at least
Right.
how I feel it, um, because there are a lot of different steps in the whole process that need to be completed. Looking back on it, it's a really good thing to have a definition of done. I mean, to know when a certain feature is finished and how to tackle those. So big companies excel at that, and that's the sole reason I switched from a smaller company to a bigger one, because I was curious to see how that's done in bigger companies and how the same, well, different people approach similar problems in
Okay.
terms of processes, in terms of how the code quality is, how the code is written, how delivery is done, etc., etc. Um, on that note, if, at least this is my personal opinion, if you are a beginner, going into a smaller company might be way more efficient for you.
Right. Okay.
uh, because you get to experience a lot of stuff really fast, and you have to adapt really fast to different and changing environments, and that's really not that typical of a bigger company. And a bigger company, you're just usually doing your own job, and you don't have to, there are other people that take care of other things, so everyone has
Yep.
his own job there. In smaller or startup companies, you have to survive, you have to do QA, you have to do analysis, you have to understand what the client really wants, because what he says he wants is usually a different thing to what he really needs in the long run.
Right. That's a really good observation. I also share that sentiment too. Like when I have folks reach out to me and say, "Hey, like I'm trying to get into the industry or I'm applying to jobs. Like, what do you recommend?" If it's because a lot of people will see big tech and they're like, that's where I want to be, obviously. And it's like, well, like I'm at Microsoft now, and yeah, I love it at Microsoft, but at the same time, all of my earlier years, like my entire career before Microsoft was startups, and I feel like if I did not have those startup experiences, I would not be where I am today, and that's no fault of Microsoft or big tech, but I think to your point, you are moving at such a rapid pace. My goodness, I can't speak. Moving at such a rapid pace in a startup
Yeah,
company, and you're wearing all sorts of different hats. So you're doing so many different things, right? Like you might say at Microsoft, I may never be able to have a customer interaction again in the space that I'm in.
yeah,
And that's just the reality. My customers now being on a platform team are other engineering teams. So, sure. But in terms of end users, that's not the case. Whereas at startups, almost every single one of them, if I needed to, I could be exposed to like an end user and get the feedback or have a conversation. So it's it's just a very different experience in terms of how you focus on developing software. The part that I think is interesting with respect to architecture, because this is something else you mentioned in your intro, was that architecture affects so many different things in software development, right? It's not just like here's how the code is organized, like that's a part of
yep,
it, but you start to think about how is this going to affect deployment? How is this going to affect our ability to test? How is this going to affect if we have multiple teams working on this? Like it really can have an impact on the development life cycle. So I I think that when you have exposure to customers and you can start to understand, like, look, we got to deliver value to customers. That's your goal, right? We have to do that. If you're balancing those types of thoughts with what does our software architecture look like, sometimes you have very interesting things that you need to consider to allow you to continue to deliver, right? It's not just, is it perfect? So, where I wanted to go with my next sort of questions here is okay, you got to build something new for a customer, right? Um, how do you start thinking through the architectural patterns that you want to lean into, right? Like, do you just do you go with your favorite? Do you like what type of thought process do you have to put in when you're building something from scratch? And it's a very open-ended question, so I just want to hear your different thoughts about how you might approach it.
I have a small book there, if I can grab it
Yeah,
real
for
quick
sure.
from the shelf.
But before we move on, this is just a reminder that I do have courses available on DomeTrain if you want to level up in your C# programming. If you head over to DomeTrain, you can see that I have a course bundle that has my getting started and deep dive courses on C#. Between the two of these, that's 11 hours of programming in the C# language, taking you from absolutely no programming experience to being able to build basic applications. You'll learn everything about variables, loops, a bit of async programming, and object-oriented programming as well. Make sure to check it out.
So, to answer that question, it's usually on my end, at least,
Okay.
is getting to know the business area of the customer. At least in the other company, in the smaller one that we worked on, we had a really high density of projects, let's say so. So we had a lot of smaller scale projects. We had
Okay.
larger scale ones that the largest I think was about 4 years into the whole company. Well, the whole team was working on the project for about 4 years. It was an ongoing live uh, authentication system. Well, basically, it was using Azure Active Directory to manage access to all the sorry, to manage access all the to manage the access to all the applications for that specific customer. So we were working with an IoT company for a
Okay.
longer period of time. So we kind of knew the area of business where the customer is coming from. So that's probably the first thing you need to understand is basically to see where the customer is coming from.
Hmm.
Also, take a look at probably if you're building software for a competitive market, maybe take a look at other similar softwares that are on the market that are doing the same thing. Essentially, you're not going to see the entire architecture behind the scenes
Sure. Yeah.
for those apps, but you're going to get the requirements and the functional parts. So there is a book I really liked at some point. It's Exploring Requirements. Okay, so it's mirrored probably.
No, it
Uh,
actually is coming through clear. It's perfect.
okay, yeah.
That
So
always
it's
happens where
Exploring
I'm
Requirements.
wondering when I hold up something with words, I'm like, oh no, is it is it mirrored? No, but that's yeah. So exploring requirements, quality before design.
Yep. So essentially, you can see how many bookmarks I have over here. So I really like this book. It's mostly about first getting the requirements
Okay.
down right before starting to design anything for your client. The next thing is basically just a small analysis of the client. If it's a big corporation with plans to enhance this specific product, but you're not going to know that for sure from the get go, so you'll have to tackle the whiteboard problem, which is the architect's worst nightmare, because when there are no constraints, no obvious constraints on the
Right.
board, you can over-engineer the heck out of a solution. But when you start to dig
Absolutely.
down, you can get those constraints, and usually those constraints will help you clear a path to see how you're going to build up your solution at the initial stage, because businesses changes over the last couple of years. You can see how many things changed along the way. So yeah, uh, depending on the client, you might go with one, and depending on the team or teams, you might go one of the other ways. For 90% of our clients, we were okay building a monolithic solution
Sure.
because, hey, they didn't have, first of all, the teams, they didn't have the constraint that they
Mm.
needed to go with microservices. Most of them wanted to go microservices first. So
It's
hey,
a
we have four
common
develop.
thing we hear now is like a lot of people,
Yeah,
jump to microservices. It is shifting a little bit, but yeah.
yeah. At least I've seen that from where I come from. It was like we have four developers. We need 20 microservices. Okay, you might
Why?
deploy. Yeah, what is the reasoning behind? And usually it was either a monolith. Then we learned how to build modular monoliths, or how is it called right now? The popular terms modular monolith that's coming everywhere. But essentially, it's decoupled software with different logical areas of your application that you need to, and each logical area is representative of a specific area of business or area of volatility around your entire system.
Right.
Um, and then you scale and rinse and repeat from there. Essentially, you start up small, you get a POC somewhere. Usually, POCs are really good starting point because you can get customer feedback, and then you can scrap that POC and build a really good software in its place. Essentially, you can deliver some POC feature, see how the customer reacts, see how much value it brings to the customer, because they might think that, hey, our users need this feature,
Right.
but you deliver the feature and then the users do not use it at all because apparently they didn't need it at first. So there is a really good book about that, From Zero to One, I think.
Okay.
It's about startups. I think it was Lean Startup and From Zero to One, which I read way back when. And I got those ideas from there and tried to implement them in software. So you get a POC, you see how it behaves, then you design it against the, you design the right thing then with
Right,
all
because you
the
actually
constraints.
got feedback, right? You ended up
Yep.
hearing like or observing through metrics that this is what people are using, this is what they want. Now we actually know versus someone saying, "I think this is what we want." Because you said it multiple times, and it's very true that customers will tell you like, "We want this," and it's like you can't just do anything and everything a customer says because you have to
Yeah.
sort of interpret like what are they actually like, what challenges are they facing, right? What are their real problems that we're trying to solve? Because if they say we want this, a lot of the times, and it makes sense, but they're proposing a solution almost, and it's like that's not the customer's job to propose the solution. The customer's job is to express their challenges to you. And you, as the engineering team, you come up with the solutions to those problems. So I had a question, though, about uh, POC. So if you're going to do a proof of concept, especially for someone that is very interested in architecture, we talked about sort of over engineering, and a proof of concept is very much on the exact opposite end of the spectrum, right? So how do you balance, or how do you shift your mindset to go, we know that we want to build something awesome with good architecture, but right now is not that moment, we need a proof of concept? How do you kind of shift into, it's POC time, here's what we got to focus on, not over engineer?
Okay. So the main shift there, the main thing there is for me well-defined interfaces or contracts between
Okay.
uh, your parts. If you have a well-defined interface, a well-defined contract for your functionality, you can switch later on the implementation details to
Right.
that part. So you can first go with it's similarly to TDD, how they are doing the approach to test-driven development, where you first write the minimum amount of code, but you still focus a lot on the contract part because that's not gonna change, and that's gonna be a hell to pay if you don't get it right from the get-go.
Yeah.
Because we've had to at some point maintain about three versions of the same interface, so three versions of the same API, because some of our customers didn't want to update to the new one, and we said hell to that after a while and
It's a
forced.
big cost. It's a huge cost
Exactly.
on a development team to say we got to keep this thing around and like doesn't have the parameters we need, doesn't have the functionality that we want to be able to provide. Like it, yeah, like I've been there.
Exactly. Yeah, so we've tried that once, went for a couple of months to and learned that the hard way that that's not going to be maintainable in the long run. Sent an email to our customers that hey, we're good with you for another couple of months, so be good and switch to the new version of the interface and
Right.
everything else because we're not planning on maintaining those any longer. So yeah, first contracts, that's the part that is non-negotiable on me because getting the contracts right, you can then switch the POC back to a really good implementation if you need to do that.
Okay.
That's why I kind of liked the modular monolith and microservice approach, well, because you have physical boundaries and you have logical boundaries, and you can work with logical boundaries way easier because you define a logical boundary and then you can swap the implementation details at a later stage if you need to. If that POC didn't fire up, okay, we might switch it to some better looking code, but not invest heavily into that specific area, into those functionalities.
Sure. That makes sense. And do you find that so if you're working with other people on your teams, is that, do you find that it's difficult for engineers to get in that mindset of being like, so you have your boundaries set up and you're trying to explain to individuals, and I don't, maybe I don't want to over assume how you approach things, but is it really a matter of like, hey guys, like we don't need this to be the most perfect architecture after the boundary. We need to get to results. Or like, how do you approach it, and how do people respond to that? Because I've experienced some things with POCs before, and I'm curious what sort of what your experience has been.
Okay, I'll cut to the chase. I was in that camp where I didn't want to deliver bad style, bad art. Well, not bad, working code base
Sure.
that was messy. I was paramount of doing everything the right way and having the entire setup, but usually it's an experience that matches throughout your career where you burn really hard because of a mistake of over engineering that you did, and then you learn the hard way that, hey, we might have had better luck going with a simple approach there and not waste so much money of the customer, god forbid, on a specific feature. There are the junior develop well, not junior developers who didn't have that kind of experience
Right.
tend to write that kind and be paramount of good quality software. For me, one point was when I joined the team and the architect there, and I came to the solution, and we had some message handlers that were message handler, and the class name was underscore v2. And I'm like, okay, we have underscore v2. Why is there no interface common for message handlers so we can, when version 3 goes on, we just create a version 3 and then we implement that interface, register it in the DI? He was like looking at me, okay, why can't you just create a new class and just switch it in the DI? And that's basically it. And
Right.
you're done. It was technically not the ideal solution, but it was working and it
Right.
was really easy to follow along in the long run. So when you have to maintain a solution, that's probably when it hits you that, hey, there is good code, there is clean code done by all the standards of DDD, test-driven development, clean architecture with all the boundaries, and there is the middle ground where, hey, this is workable, this is easy to maintain, this is easy to develop further. We do not lose that much velocity in our sprints to develop new features. Yeah, of course, there are some things that need cleanup, but we can address them in the long run. So that's usually the sweet point that you come after some form of experience there.
That that makes sense. That resonates with sort of my experience. I know before Microsoft, I did a lot of prototyping at the digital forensics company that I worked at before. So I had small teams, and we would kind of set out to go try things out. And it was, I think, for the engineers I had on my team, like we were in the mindset of like, we understand what's involved with building higher quality software, but we're like, we just know that we need to get to answers. And we took that to, and this is like sort of right before I moved to Microsoft, but the team itself was starting to look at things like, if we don't even need to write code and we can get the answers for how we want, like the what the customers are actually going to need, if we don't even need to write code, then like let's save even more time and not even write code. But we
Yep.
noticed it's pretty typical, like sometimes people would look at a team like that and they go, it's not fair. You guys get to work on like the latest technology. It's all the cool stuff. Like, why don't we get the cool stuff? And it's like, that's not really what it's about. The big challenge is that a lot of people aren't ready to basically throw away all of their work, right? We're going to try doing something and we have to expect that it's not going to be okay. And we have to be ready to say, sorry, it didn't work, and just toss it and move on to the next idea. And I think that to your point about having experience doing this type of work, it's because I think you caught yourself. It's not even like a junior versus senior thing. It's specifically
Yep.
this type of work. You need to be of the mindset that like the goal of this work is generally getting to answers faster. If that's the goal, if you go through it and you're trying to write, what perfect code might look like, it only takes a few times where you're like, man, I spent so much time doing this to get it perfect and we had to go toss it out. Like, why would I do that again? Like, it sucks.
Exactly. What we did there also pretty good on your point to get feedback from customers was we had an amazing UX UI team that they had prototypes And I don't know how they were doing. They were basically creating the whole platform in Figma, I believe it
Cool.
was, and they were able to click through the images. So basically, they
Nice.
added some kind of behavior to the UI part, and they were validating. They were working a couple of months ahead of us
Nice.
on validating the requirements. So they were going to the customers that, hey, here is the UI part. They were also they had an amazing guy there who was also checking usually with the developer team that, hey, is this feasible? We can draw it really easily, but is this feasible for you to get there? So they were writing those designs and they were validating. So when development phase came in, or when we had to, well, when development phase came in, we usually had a more or less a rough idea, a really good validated rough idea of what we need to build. So we didn't have to throw away some stuff, uh, because that's the hardest part. Throwing away your child after you've built it up for a couple of weeks and then throwing all that code away, that's the hardest part. And you have to go
Yeah.
through that a couple of times in order to get used to that. I don't know if there is any way to psychologically prepare for that kind of thing.
Yeah. It feels like a very big waste. And no, you made a good point too. I think the depending on the teams we had, there were certainly cases where we had our product owners working with UX designers to get mock-ups and putting them in front of customers, which is good. On the prototyping team I had, that was almost collapsed into the team itself. So depend like our product owner might be in a position where he has mock-ups and he's already talking with customers, getting feedback. Because
Exactly.
to your point, that can really help get ahead of the curve and reduce the amount of waste. But at the end of the day, the goal of proof of concepts, regardless of whether it's in code or it's a PowerPoint or it's Figma and you can click through things, the goal is really to kind of validate if an idea is going to solve problems. So um, very cool to hear that it's kind of like similar sets of challenges. People, it's like a mindset shift. People they want to do good work as software engineers, and sometimes the POC realm kind of makes you feel like I'm not doing the good software engineering things. Like this doesn't feel good. So yeah, it's a definitely unique experience.
Yep, yep. There is a point there also to know when to shift from a POC to a real to get more return on investment. So there is a
Right.
point, at least currently in my current project, we have a lot of we have some POCs, and we've missed a couple of opportunities to move from a POC to a really good implementation. And we paid the price a couple of weeks later that, hey, we really needed to have that stuff already done, not
Mm.
only have it via the POC. So there is a fine margin there also.
What does
And
that look
to that
like in
point,
terms of observing when that change may need to happen? Right. So you're doing a
exactly.
POC. You're like, hey, it's working, but yeah, like what are some signs like, hey, maybe this needs to become a more real thing. Maybe we need to do a better job on the design as we go forward, or scrap parts of it to go rebuild the parts now that we know. Like, can you walk through some considerations there?
Um, Usually it's the point when you realize that doing something in the, well, at least in my experience, was that doing a repetitive thing right now uh, will cost you more than redesigning the thing and, well, doing the POC right, well, doing the implementation right.
Okay.
Because you should have good metrics, and you should usually, again, back to the requirements part and back to the analysis, market analysis and all that stuff, because right now we're working on a live project. So we had some functionality that our customers could use, started using on certain pages. And when we realized that, hey, we need to add this functionality to other parts of our entire system, to other parts of our thing, and it will basically mean that, hey, we need, let's say in story points, we need 5 story points to implement this in another part of our system. Then you take a look at how many places you need to implement that in, and you start adding up, and you understand that, hey, this is no longer manageable. We need to find a better solution. Maybe spend 10, 15 story points worth to get the solution down, but then get a return on investment really quick and basically get it up and running. There is a fine line there, and it depends probably on the systems and depends on the business part. And usually, developers are, from what I saw and from how I was very narrow-minded on the functionality itself. So you
Okay.
need to take a step back and try to see for yourself the bigger picture. And that's the hardest part for me. It was just stepping back and not seeing the forest for behind the trees. Yeah, that's the hard part. For science, it's basically you spend a lot of time. You spend more time that you expect nurturing or doing specific stuff that you expect it to be just a POC or one time of stuff. So
Right. But it's I think to your point, like you start using there's a bit of gut feel, but also like you're trying to use data to say like
yeah,
if we know that this is where we want to head, and like you mentioned story points for other folks, and if you're using different systems of
yeah.
estimating effort and stuff, the point is really just that you're starting to realize like if we have to go repeat this and this is the amount of effort it is, what does it look like instead if we, I'm going to use air quotes here, like do it right or do it better, do it differently? Can we shrink that down? Because the point might come up like we know there's, I'm just making this up, we know there's 5 spots we want to do this in, but that's 5 spots today, maybe there's more in the future, we don't want to keep paying this cost. So I think that's a really good way to look at it, is like it sounds kind of funny again, right? But if you were to look at that and say we got to do it in 5 spots, but to redesign it is actually going to be even more work, you might just say screw it, like it must be good enough for now and we'll just keep it. So then you don't transition from maybe what was a proof of concept with maybe slightly rougher architecture, you just say like it's working and keep it.
Oh, yeah, yeah. To that point, the story thing is you named the term right. Effort. That's the word I was looking for. So it's the amount of effort that you'll need to do there. So as you said, it might be 5 places right now, but we're not going to use it in the future anyway.
Right.
So there is no prospect of using that functionality in the future. So that's where usually your gut feeling and how your team and how you've been doing stuff on the project kicks in. So that's where you should take the decision. And I cannot advise right now, and I will try to not advise anything at this point because it's very well, it's very situational and based on the project itself. So any advice I can give right now or from my personal experience might be interpreted the wrong way around and
Right.
taken to the extreme. So yeah.
It's a very difficult thing when you're sharing information and experiences. It's like you want to be in a position where we can offer advice, but it comes with a bit of a risk, right? Like people need to understand that, and it's probably one of the most important things in software engineering. And we joke about it, but we keep, programmers and software developers, we always say it depends, but like it's because it does depend. The context that you're working in determines so much. And it's like you might, and I'm guilty of this, right? Like I use C# for everything. I basically default in all my own projects, I default to like a plugin style architecture for everything. But I do these things because I don't have other constraints generally. If I'm just building stuff for myself, I'm building it how I like, right? But that's the context. If I'm building something for a customer, or if I'm building stuff on teams of people, if I'm building stuff at work in an existing code base and stuff, I don't just go, hey everyone, guess we're switching to a plugin architecture, sorry. Like it's there's so much context that when we're talking about our perspectives and opinions, we need like hopefully it's assumed, but unfortunately it's not, but it's very important how much context that is provided there. So totally get it on the advice offering part.
On your thing there, if we return a bit to the topic of testing, I had
Yeah.
that experience a couple of, well, some time ago, uh, where we were deciding on a front end library, well, front end framework for end to end testing. So we were using Cypress at that point, and we decided to switch to Playwright,
Okay.
which is written by Microsoft. And I was familiar with Playwright and writing code in C#, And the first thing that I came to is like, hey, we can use Playwright and write C# code in order for the end-to-end tests. And then it occurred to me, wait a bit, but do the QA guys know C#? So yeah, it's better. We defaulted with Playwright, but we went with the JavaScript part with the implementation because they didn't need to learn C# to get the stuff there, so they could use their own language, the JavaScript, which they were familiar with. And the constraint itself was, but hey, they're gonna waste some, they're gonna spend, better say, some time learning that new library, and learning
Mhm.
an additional new language is gonna cost you too much, while you can get the same return on investment with the Playwright in JavaScript. So we went ahead with the JavaScript, and that's a constraint that had to that influenced our decision in the long run. So
Yeah, it's a
yeah,
great example, right? It's like there might be things that it's not exactly what you love based on your personal opinion. It might not be something that you've used consistently over. You might have seen an architectural pattern or a software like tech stack. You might have used it 10 times before in the past, and you're like, I know how it would apply in the situation, but the team you're working with, those individuals might not know it at all. The domain that you're going into may not be a good fit for it. Like there's so many considerations, right? So on testing though, have you, and this is, it's going to be a, like maybe a very open-ended question, so I'm not looking for like a specific answer, just a curiosity. Like when it comes to thinking about testing, when it comes to software architectural patterns, how much does the goal of having like good tests, good as in what, however you'd like to define that, how much does the architectural decisions influence your ability to have good tests? Like is that something you think about, as in, hey, we're going to use this type of architecture because it gives us a good ability to test, or is the testing part like a, we'll just figure out how to make it work after?
uh, I'll say it right out. Well, I said right out. I've been blessed with the team and the QA guys that are really capable of, and when I joined the team, I learned a lot from them. So they were really amazing at different stuff. So I've learned how they approach testing in itself. So um, I would say that the architectural decisions influence the approach you take for testing. You can
Okay.
still get really good test coverage, and I don't really mean test coverage by lines of code, but I mean by functionality part. You can get a really good testing suite there with nearly any kind of architecture, let's say so, depending on your specific skills. So let's say the main criteria that I use to define when we have a good testing suite is we're ready to deploy on a Friday evening without any care. So we just press the deploy button and we go home without even checking the deploy pipeline on the
I'm glad
PC.
you said it. I'm glad you said it because that is 100% my philosophy. Because everyone says, I do that because I don't want to have to come in on a Saturday. And I go, yeah, I don't want to waste my Tuesday having to fix stuff from Monday. I don't want to waste any day fixing stuff from the
Exactly.
deployment before. So why is the weekend any different? If you feel that the weekend is a special time and that's why you can't deploy on a Friday, I'm like, what's broken in your process that doesn't make it automatic? And I know it's easier said than done, but I truly feel like you should be looking at that with priority.
Yeah, exactly. Because the lines of code do not matter. I've seen in my experience hundreds of useless tests that were there and were basically testing mocks. So I've seen that when you have a class, let's say, since we're talking about C# here, we have a class with a couple of dependencies, and all those dependencies are mocked out, and you're basically testing how you're calling those mocked out dependencies. Yeah, there might be some value in those tests, but I don't feel really convinced to deploy something with those kind of tests because there are hell of things that can go wrong in there. So we're trying, at least right now, we're trying to cover as much ground as possible in any different scenarios. And we're basically not using one type of testing to get everything there.
Cool.
There is no universal silver bullet or whatever you call it, universal solution to everything. You just need to, it's part of a gut feeling, it's part of an engineering approach. It's a mix of the two, where you know that, hey, this part of the system is really, really critical. So we should cover it up with different kind of tests, not only unit integration, maybe add some end-to-end tests for user journeys, see how the entire thing works out. This part is okay to unit tested because there is some domain logic in there that's not really doesn't really depend on any other parts of your system. Uh, we focus a lot on integration testing because usually integration testing is where things go wrong. And integration and slash end-to-end testing, with all my love for end-to-end testing, they're really useful when push comes to shove because and in a good amount. I mean, you should not go overboard with end-to-end testing there. Uh, better, I could take a step back here and just approach different testing approaches for different companies, because in my previous company where we had uh, mostly QAs and we had no mostly manual testers
Okay.
who were doing the clicking on the side, uh, a really good return on investment were those end-to-end tests written in Playwright, because the tests themselves were pretty easy to set up. Well, pretty easy because the solutions were easy. The entire setup process was done by developer, obviously, but then the testers could step in and write some basic code that would fill in some forms and just cover a lot of ground and just get a lot of return on get a lot of value out of those tests really easily. It wasn't covering the entire system itself, so but it was usually making the life of the testers way easier and
Hmm.
way easier to work with the entire thing. Then come unit tests, which basically cover the innermost part of your system, the domain part, which is usually where I find them useful, or from some utilities part, which don't have many dependencies on external factors. Integration testing is usually the part that I love most, and depending on what you call unit and what on what you call unit, we may be talking about the same type of thing
Sure.
in the testing. I've had some discussions in the past where the terms were mixed up and we were talking about the same thing but in different terms. So that's usually the first thing that you need to do is get your terms right there.
Yep, I've definitely observed that, especially when sharing, especially with tests. Like people have, I might be calling an integration test and I generally call like an integration test and a functional test the same thing, just because that's how I'm used to referring to them. And someone might say they're different. Here's why, and I'm like, okay, call it what you want. Here's the thing I mean. But no, there's a lot of stuff like you and I haven't talked about this before, so it's really cool to hear as you're going through some of these experiences. Like there is a lot of overlap in some experiences I've had where at the digital forensics company I was working at, there was a lot of okay, two sides of it. One is that we have like basically a search engine, so that was like a huge end to end test in terms of data perspective, right? So we would run a search programmatically. You don't care about the user interface or anything. It's just, do we get the data that we expect? But it's an enormous end-to-end test. But we had a lot of manual testers, and when we would go to release software, at one point in I don't know if they've completely moved away from this since then, but there used to be like what we would call like a build verification test plan, and testers would go through like these cases and basically click through the application to make sure that they get these expected behaviors. And we started to go look like those build verification tests take so much time, and like a human has to do it. So why don't we programmatically get something to click through, validate, because it's so repetitive. And it's the point here is not like, hey, the test isn't valuable. It's just that you as a human being have so much more value that you could be offering if you weren't just clicking. So I always want to be clear about that I'm not saying that like people doing manual testing aren't valuable, or that those types of tests, those scenarios aren't valuable. It's just that I think that humans have way more value when they're not repeating things. So we moved towards that. And what we found was, you kind of were saying, this is an interesting part, that the setup for those types of tests could be done by a developer was actually pretty lightweight. And then the QA, the testers could go actually write a bit more specific parts to fill things out. But I think those types of tests work well when your setup is actually not super heavyweight. If you're sort of, your system isn't going to be super brittle, that if you change one thing, your 300 test cases now all have to be touched. So we've encountered that kind of stuff too, where like it's, I love that you said it's not just one type of test, right? You have different types of tests that you exercise in different scenarios. They all have trade-offs. There's so much good about what you were saying there. I wanted to ask you a question about, because I have strong opinions about mocks and stuff, but only because I've actually had, and this is going to sound very odd, I've had a lot of success on one particular team I had in one project that we did. I should say product. It was more than just a small thing. We literally only unit tested with mocks across the entire code base, and it was done to like an extreme. So it was almost like a, I don't want to say it was just like a, it's not a joke. It was more like, can we do this, and is there a benefit? Like almost like a test of like, what are the limits of doing this? And we unit tested everything. And what was really cool on that team, and this is why it sounds funny, is that we acknowledge that mocking everything and only unit tests is not, like, it's just not a good strategy to do only one perspective. But what was really cool was that when we mixed that with telemetry, when we could watch telemetry reports of an exception happening or bad behavior, and we could go to our code as the engineers and go, oh, we missed a test case. Like literally, there's the bug, there's the missing test case, add the test, fix the bug, and we could do it and basically push the update before our tech support could even let us know. So we had a very interesting feedback loop. But anyway, I'm not saying that's the best way to test. I just thought it was an interesting example of taking it to an extreme. When you think about mocks, and you mentioned that when you have few dependencies, like basically it's a better situation for unit testing. And I would agree, right? You can isolate because you don't have external dependencies. You can just focus on some code. What are your thoughts about mocking out external dependencies, like say third party services that you have no control over? And I don't mean a database, because a lot of the times now with our testing tools, we can stand up a test database like locally on our machines or in CI, and we can do that, tear it down. But I mean like pick a service that's that your company doesn't own, some third party API that you have to access, but you don't control it. Like, do you use mocks in that situation, or do you have other strategies for testing?
We had there's two parts that I want to say here.
Yep.
So first of all, we had in the past the exactly opposite part. So we
Okay.
went with the strategy to go with only integration tests and few unit tests where possible. So we kind of got the other part, other. So we got the other part of the spectrum itself.
Right.
So we got there with integration tests, and we had some unit tests. So we were testing from outside in the entire
Right.
system. So that's usually the points where the inside the system points, and then the points where the system communicates with some other components, other models, other stuff around other systems themselves. To your question about external dependencies, we had, I'll try to be as close as ambiguous as possible, not to
Sure.
break the NDC. But we had a case where we had Azure Active Directory, which we worked on on a system that was creating user accounts in AED B2C, business to client part. Uh, but we were importing some users from Azure Active Directory. So at some point in our unit, in our integration test suite, we had to integrate with Azure Active Directory. Because creating users in Azure Active Directory and creating test users would cost a lot of money for the customer. We settled up on creating a couple of accounts, a couple of test accounts that we would usually use for our testing purposes. So we had an issue when two different pipelines would start at the same time and would reuse those users. We would have flaky tests because we were interacting with the same instance. So one instance of the pipeline would create that user. The second one would assume that the user is not created and would try to recreate that user into B2C. And then we'd have flaky tests. So uh, we had those issues. And I would say now, post factum, how I would approach that situation right now and how the solution we did there was basically to push the integration with the real instance as far right as possible.
Mm.
So we run those tests at the last step. So even if a couple of pipelines start at the same time or stuff like that happens, usually it's going to be only one that ends up at that stage in time. So we tried to push in the whole process, not really pipeline, in the whole testing process, the integration with that third party as far away as possible and use mocks until then. Now I would, let's say we're integrating with a third party API, and I was looking at two things, contract testing and using stuff like wire mock, essentially because you would, for example, mock out a third party API on your end. And we had in microservices, because right now I'm working in a microservice environment with a lot of different teams. Sometimes some teams break their contracts.
Yep.
Some APIs break their contracts. So even if you're using, and you might be testing against mocks, against well-defined mocks, but you're not catching those times when those contracts are broken. So it's totally fine to test against mocks. And if you have some other practices in there to cover up for the spaces or for unforeseen events like contract changes, behavior changes, and stuff like that. If you're testing, if you don't have any way and you need to test against a real instance, I would push it as far away to the right as possible and bring to the left the stops, because those will get you faster up and running. And then you can, at the last stage, just basically test against the real instance. There is a risk there as well that if the third party API changes his contract and you catch it only at the end, that's going to hurt.
Yeah.
But that's where other types of testing comes into place. So like contract testing that I mentioned before.
Yeah, that's a really interesting and like a good I say good. I say good only because I think it aligns with my perspective.
Response.
So it's subjective. Just trying to
Yeah.
acknowledge the bias. I think it's a good perspective. It's very much in alignment with what I've experienced. Where um the even the idea you were mentioning with wire mocks and stuff, right? Like it's interesting because you can basically have like API responses replayed for you that are legitimate, and like you know that you're working with something that was real. And I think for in some situations that can really help for when people are saying like, hey, you don't know the behavior of that thing, you're just making it up. And it's like, well, no, this is a replayed response, so like that was real behavior, so that can give you really good confidence. But it can be false confidence in terms of that's a real running system, and if they like they're you shouldn't have to go test their system. You want to test the interaction with it, but you shouldn't have to test that their API does what they say. But it's possible that it breaks, it's possible that it changes, and if you're not in a position where you ever have a signal for that, like you may run into problems. So the thing I wanted to bring up again was back to the product I worked on that was heavily unit tested with mocks. The thing that we ran into at the end, and for context, this is for mobile phones. So we basically did digital forensic. Yeah, we did digital forensics extracting information from the phones. And the reality is, even if you leave a phone sitting there, like it could do updates. right? There's all sorts of things that could happen, or yeah, like whether it's the OS or the applications that are on the phone, they can update. So there would be situations where our tests would just stop working, and we're like, what the heck? Like, I got to back up because I said that wrong technically. We ended up having to build this system where we were working with phones so that we could detect those things. Before we had that only with mocks, we would just assume we were good because we were effectively replaying known state. And then we would have customers going, this isn't working. And sure enough, we would go try a real phone and we were like, this used to work. Why doesn't it? So we did build like a sort of this, we went from completely only unit tests with mocks to the only other thing we added in was this hybrid thing that could basically just check if contracts were broken. And if the contracts weren't broken, we were like, we know that we're so heavily unit tested that everything else is fine. But this other thing was our signal to tell us, like, every night it would run and be like, something broke on Samsung phones. Like, buckle up because now tomorrow is going to be a big investigation about what to go fix. So anyway, I just thought it was super cool to have, like, you can refer to testing some interaction with mocks and it will give you some type of confidence. But even over that same boundary, you have a different type of confidence with a different type of test. So if you're truly interacting with that API that's, third party thing, you start to get a different confidence in that integration. So I thought that was a really cool way that you navigated explaining, like, we just use different tests and even over the same type of boundary you might do different things. So that's super cool. Um, yeah, do you have any
Cornerstone
other thoughts
there.
on that?
Yeah, a cornerstone there is probably how easy it is for you to set up those things and how fast those tests can run. Because let's say I never said anything about dropping those tests, so that's a really good catch there. You should obviously test against the real instance at some point. When that point comes, is it sooner for you, is it later for you? It's basically really constraint dependent on your end. So that's really for you to decide what kind of approach you're going to take there. But you should never drop those kind of tests there for any kind of thing, because integrated integrations are usually, from all my years of experience, which are not that many by this point, we've had the issues pop up not at the unit part, but at the integration part. And it might have not been just because of us. Let's say service A was working fine and service B was working fine. The network is between those services. So faulty network, it might not even be the teams that are working on the assets themselves in the wrong there. It might be some integration part, Kafka failing, messages
Right.
being dropped somewhere, corruption, network issues, all that stuff.
Yeah, how does
It
your
can
system
pop up.
handle that stuff? What does it do? Like, if you're not exercising those paths, then it's uncertainty, right? So you can do things to give you confidence around those uncertain areas, or you don't, and then if you're not running into issues that regularly, maybe you go, that's why we don't invest in it. But in my experience, it's similar to yours, where it's like, it only takes a few times for you to be like, man, this sucks. Like, those types of issues
Yeah,
are a pain in the butt. We might as well put something there to, like, give us a signal.
yeah, that's probably the reason why so many different testing approaches are there in the first place, because I mean, smarter people than me or probably got some problems to those problems earlier than me. So it's an engineering job just to figure out what kind of problem and how others have solved those
Right.
things, and just compare the constraints they have compared to your constraints.
Yeah.
And it's not usually technical mumbo jumbo. You can take approaches from other languages, other technologies, other areas of work, and adapt those to your specific needs and see what works really for you. Because at the end of the day, it what gives you confidence in deployments on Friday.
That's exactly it. That's the way I always frame it, is if people are debating about, the best way to test and stuff, I always come back to tests are there to give you confidence in the changes that you are delivering. Nothing more, nothing less. And I think if you always come back to that, it makes thinking about what you should be testing and how you should be testing a lot more straightforward. It gives you flexibility and allows you to do the right thing. Um, Vasily, as we wrap up, you had mentioned that you have a course, and I'd like to hear more about your course. And if you want to share with the audience about what the course is, where they can find it, I'll make sure to get links and stuff from you after, but would love to hear more about the course that you have.
Sure, sure. So I've been working a lot with modular monoliths, and at some point I had way too many questions addressed to me, so I wanted to cover them all up into a single source.
Cool.
So basically, uh, it's a lot more on the theoretical and on the design part
Okay.
focused. So it's about modular monoliths, how we were building them, and what were the constraints, what were the ideas, and what were the decisions that we took to get down to a specific situation. Because I cover a lot of different approaches on how you can build modular monolith and then scale it out into a microservices system, because we've done that in the past, and basically approaches that have worked for us, experiences that I've had, uh, all concentrated into a single source. So that's basically what that course is all about how you can build software, how you can build pragmatical software there that you are sure that you will be able to run and to bring value to your client.
Awesome. And it's cool that it's based on, experiences that it's like you mentioned, it's not only just the theoretical part of here's how this stuff would work, but backed by, we did things a certain way and here's the outcome of it. So I think that's a
Yeah,
very valuable thing to add.
that's the part that there are many courses there that explain technical stuff like do it like this, and but the why part is not usually that well covered. So I try to focus more on the why part and also give some technical insights into how to do that stuff.
Right. The why is it comes back. We were talking about context, right? Like someone might hear, "Oh, modular monoliths. I know everyone's talking about that. I just have to go do that." I think that's what happened with microservices, right? Everyone's saying it. I have to go do it. But when you hear about the why, I think that's what gives you, like, hey, if I understand why we do things, then I can see if my context is applicable. So that's super awesome. So Vasily, I'll get the link for that from you. What about if people want to reach out to you? Where can they find you?
uh, They can find me on LinkedIn. I have my page on LinkedIn, then you can write directly to me. And I have also a YouTube channel where you can watch other stuff I post
Awesome.
around. So over there, I think you can, well, I think you can leave comments and I'll try to replay as ASAP usually. But yeah, LinkedIn is usually the place where people reach out to me.
Awesome. Okay, we'll get your channel linked, we'll get your LinkedIn linked, and we'll get your
Thanks a lot.
course linked as well. So I'll make sure I
Yeah.
get all of that from you. Vasily, thank you for this conversation. It was refreshing for me to kind of hear some things validated, also some different perspectives on how you kind of navigate software architecture, how testing ties into things, and truly the value that both of those things offer in developing software. So thank you for making the time.
Thank you very much for having me. It's been an amazing experience for me here.
Cool. No, I'm glad to hear it. Okay, we will chat soon. Thanks, folks, for tuning in. Let me know if you enjoy this kind of thing. Do the like, subscribe, comment, all that fun stuff, and we'll see you next time.